6,000 planets, 0 moons, not one. We've found lava worlds, iron cloud giants, planets orbiting dead stars. But in 30 years of searching, no moon has ever been confirmed around any of them. Our own solar system has hundreds, oceans beneath ice, volcanoes in the void, worlds that might right now be sheltering life. And yet the moons of other stars have stayed completely invisible. Until now. 73 light-years away, something is tugging on a failed star. It might be the first moon we've ever found beyond our sun. The problem? We're not even sure what to call it. The search for exomoons is one of the quietest obsessions in astronomy. The logic is simple. If planets are everywhere, moons should be too. Since 1992, the known exoplanet count has exploded past 6,000. But moons are a different kind of hard. A planet announces itself. It dims a star as it crosses. It tugs that star back and forth. It glows in infrared. A moon's signal is fainter, a whisper riding on top of a whisper. Easy to fake, hard to repeat. For years, candidates came and went, promising hints that faded the moment anyone looked closer. The silence was never proof that other moons don't exist. It was proof that a moon is easy to imagine and brutally hard to catch. Then a team led by astronomer Kevin Hoy tried something no one had done before. Their target, a system called CD 352722, 73 light-years away. At its heart, a small red star, about half the mass of our sun. Orbiting it, a brown dwarf, a failed star. Too heavy to be a planet, too light to ever ignite, and orbiting that brown dwarf, something else. Using the Very Large Telescope in Chile, the team watched for nearly 2.5 years. 23 measurements, almost 5 full orbits, and in the light, they found a rhythm, a repeating wobble, something pulling on the brown dwarf, something with at least the mass of Jupiter, circling it once every 170 days. For the first time, astronomers took a planet-hunting technique, reading the tiny back-and-forth shift in starlight, and aimed it at a directly imaged failed star. And it worked. Here's where it gets strange. Call it a moon, and something breaks. Because this object is enormous, at least as massive as Jupiter itself. Our moons are specks beside their planets. This one is a giant, and it doesn't orbit a planet at all. It orbits a brown dwarf, which orbits a star, a moon of a failed star, of a sun. But now consider the scale. Jupiter is vast. You could fit every other planet inside it and still have room. But even Jupiter is nothing compared to Phoenix A, one of the largest black holes we've ever found. Phoenix A could swallow our entire solar system, the sun, every planet, every moon, and not even notice. And this exosatellite, as enormous as it seems to us, is still just a mote of dust against that. Invisible, vast, unnamed. The team doesn't quite know what to call it. For now, they use a careful word, exosatellite. Not a planet, it doesn't circle a star directly. Not a moon, at least, not like any moon we know. Something in between. A word we may have to invent. And yet, in one way, it behaves exactly as a moon should. Compared to the brown dwarf it circles, it's just 2.5% of its mass. A small companion beside a much larger body. Moon-like in proportion. Planet-like in scale. It sits in a gap in our language, and maybe in a gap in our understanding too. But here's what makes this science, and not a headline. This is not a confirmed exomoon. The team is careful. They call the detection plausible, a candidate. The strongest evidence yet, but evidence, not proof. That wobble could, in principle, be mimicked by other things. That is exactly why, after 30 years, no exomoon has ever been confirmed. What they've measured is a minimum mass and an orbit. What they haven't done yet is pin the object down directly. Some astronomers are skeptical, and that skepticism is the point. It's how a candidate becomes a discovery, or doesn't. The next step is astrometry, mapping the object's true mass and the tilt of its orbit. And further out, a new generation of telescopes is coming. The extremely large telescope, with a mirror nearly 40 meters across, should one day catch moons far smaller than this one. If this candidate holds up, it's the first of a hidden population. If it doesn't, it still taught us how to look. So why does a moon matter this much? Because moons are where the story of life gets interesting. In our own system, the most promising places for life aren't the planets. They're the moons. Icy worlds with buried oceans, warm seas beneath frozen shells. If moons are common out there, then the places life could take hold aren't just the planets we've been counting. It's everything orbiting them. 73 light-years away, a Jupiter-sized shadow is circling a star that never caught fire. We can't quite name it. We can't quite confirm it. But for the first time in 3 decades of searching, we're looking at something that might finally be a moon around another sun. And if it is, it won't be the last. So it's not that we found a moon. It's that we found something that doesn't fit any word we have. And that might matter more than a confirmation ever could. Follow for more mind-blowing space facts.